Hey everyone, in this video we are going to solve the minimum insertion steps to make a string palindrome question on Leetcode. So we are given a string S and we need to return the minimum number of steps to make it a palindrome. We know what a palindrome is. Palindrome is a string which reads same backward and forward as well. So for example, if we are given this string Z Z A Z Z, the output was 0 because it is already a palindrome. But in another case, MBADM, we needed to insert two more characters here, which was 1D after B and a B before M, these two insertions. So there are a number of ways to solve this particular question, but we are going to use the same approach we used in the longest palindromic subsequence question. So this is the question. Let's see how we can do it. So we can make any string a palindrome if we just reverse it and add it to the end of the original string. So what do I mean by that? So if I have this string s mbadm, what I can do, I can write the original string as it is, mbadm, and then I can reverse the string, this string s, and add it in reverse at the end. So m d a b m, and it will become a palindrome. So m matches to m, b matches to b, a matches to a, and so on. But that's not what the question is asking. This will be the maximum number of insertions we needed to make it a palindrome. The question is asking us to give us the minimum number of insertions we need to do. So what we can do, we can calculate the longest palindromic subsequence first. So what is the longest palindromic subsequence? It is a subsequence of this string which is a palindrome and is of the longest length compared to all the other palindromic subsequence. So the longest palindromic subsequence in this case will be MAM. So what we can do, we can keep it intact. So MAM. This is the longest palindromic subsequence of this string S. And what we can do, we can check how many insertion we need to do now. So what we have here after M is a B, but we don't have a B here before this M. So what we need to do is insert another B here. Next we have a after B. Yes, we do. Then after that we have a D here, but we don't have a matching D here to make it a palindrome. So we can insert one D here. And now if we see, this string will become a palindrome. So what we can see is if we calculate the longest palindromic subsequence, which is this of length 3, and we subtract it from the length of the original string, which is 5, we'll get the minimum number of insertions we need to make this string a palindrome. Let's try with one more example. So let's say we have this string Leetcode in a variable s, and we need to calculate the minimum number of steps to make it a palindrome. So first we find its longest palindromic subsequence. So in this case there are multiple of them, which is like ETE or ECE, EDE. Let's take EDE in this example. EDE is the longest palindromic subsequence we could found for this string. We'll keep this longest palindromic subsequence intact. So we have E, we have D, and we have E. Okay. Next we traverse the string. So we have L here, but we don't have another L after E. So we'll add one L here. So we have up to now one insertion. Next we have a E here. We have a E here. They both are matching. Cool. Next we have another E here, but we don't have a matching E here. So we'll add one E here. The insertion will become 2. Then we have a T here, but we don't have a matching T on the other side. So we'll add one T here. Total insertions will become 3. Then we have a C here, but we don't have a matching C here. So we'll add that as well. Total insertions become 4. Then we have a O here after C, but we don't have a matching O here. So we'll add one O. The total insertions become 5. Now if we calculate the length of the original string, which is 8, and the length of the longest palindromic subsequence, which we found, which was 3, and we subtract them, we'll get the answer 5, which is same as we checked. So this is the question. The time and space complexity will be same, which was in case of finding the longest palindromic subsequence, which was O of m into n, or in this case we can say n square, the length of this string. Space complexity will also be O of n square, because we'll be using a 2D grid to calculate the longest palindromic subsequence. So this is the question. Let's see how we can do it in code. Okay, so I have the code for longest palindromic subsequence here. So what I can do, I can just copy this whole code, paste it here, and instead of returning the element present at the last row and last column, we have to return the difference between the length of the original string and the length of the length of the element present at the last row and last column. So it will be text 1 dot length minus temp of text1 dot length and text2 dot length, which is the element or the value presented at the last row and last column. And the whole code is as it is, which was present in the longest palindromic subsequence question. So if I run this, it's working. Let's submit it. Yep, cool. So that was it for this video. Thank you for watching.